Hello, in this video we'll look at the Poisson distribution and the discrete uniform distribution. We'll start with the Poisson. It's a little different than anything we've looked at before. It's a distribution that it tends to be skewed to the right, and really what we need to know about it is the mean. What's the mean number of occurrences? Or again, we can use success. What's the mean number of successes? Poisson is often used for arrivals. How many people will arrive over the next, at a tool booth over the next hour? How many will arrive at a drive-through restaurant window over the next day or 15 minutes or whatever. So, and it's used for a lot of different things. But basically, what you're doing is you're looking at something occurring over a time period. It could also be space, number of flaws in a 4x4 foot carpet or rug. And but we'll tend to use over time. I mean, it could be either, but more often we tend to see it over a period of time. So we need to know the mean, the average number of occurrences over a given time period, and so that's what we call lambda. That's the mean of the Poisson distribution, and so if we know that, we can construct a probability distribution. The formula for the probability that x, the variable x, will equal some number is right here. There we go. So we've got e to the minus lambda times lambda to the x divided by x factorial. So that's in your notes on the Poisson distribution. And obviously e is the base of the natural log, so 2.71828. Any calculator should have that. So you can see that it's very much dependent on lambda, and obviously then on x. So we're going to look at a distribution here of where we could take on values from 0 on, and we'll eventually stop here. It could be 100. We don't have a defined number of trials like we do with the binomial. We could go on and on, but it's as we get larger, it will tend to, the probability will tend to move towards 0. So if we use this formula for each of the x's, basically all we need to make sure we have correct is lambda. So we have this problem here. Assume that the distribution of homeless individuals stopping in for lunch over the noon hour at a local church's eat and greet ministry is Poisson distributed with a mean of 10 homeless individuals. So if we want to look at an hour, the noon hour, then we know that the mean here is 10. Okay, so this formula that I have here represents this that I have written out. So e to the minus lambda, minus 10, times lambda, 10, to the x, 0 in this case, divided by x factorial, 0 factorial. And again, 0 factorial is equal to 1 by definition. Okay, so that's has a probability of 0. So let's just go down to, and I just made up 24 here. We could go further if we wanted, but you can see that we're pretty much getting close to 0 by the time we're at 24. In fact, I believe that should pretty much get us to when we add these up, to almost 1. So we can also do the cumulative. See what we end up with here at 24, and it pretty much rounds or is very close to 1. That might be a rounding there, but so we've got a probability distribution here and a cumulative probability distribution, and we can see that probability x is equal to 12. So what's the probability? 12 homeless individuals will arrive. That's just that value there. Probability greater than 12, we would take 1 minus the probability x is less than or equal to 12. Okay, because we're still dealing with a discrete random variable here. Okay, probability less than or equal to 7. Well, that would be that there. Probability less than 9. That doesn't include 9, so that's the same as less than or equal to 8. So those would be our probabilities. Okay. So as long as we just know this formula right here, we can construct a probability distribution. Now there's also a table, just like with the binomial, there is a table in the appendix of the textbook, and again it will give you the cumulative, and what you basically just need to do is find the lambda. There's no n involved here, just find the lambda for the time period that you're interested in, and you can find the probabilities based on the cumulative probability that's given to you in the textbook. Well, you can also use the Excel Poisson.dist function here. So if you identify the x value, identify the lambda, and then tell it whether you want cumulative or the probability. So if you want the probability, just put 0. If you want the cumulative, put 1, and then you can let's see if I can do it this way. Maybe I can end up with, yeah. So I end up with exactly the same as using the calculations. Using this formula here, we could also find the same probability distribution using the Poisson function. Okay, and so also you could find the expected value. Well, the expected value is the sum of x times probability of x. We already know that, so I've got that set for us. And then the variance is, using the shortcut method, is the sum of the x squared times probability of x minus the expected value of x squared. And notice how those are exactly the same as lambda. So lambda is the mean and the variance of the Poisson process. Okay? And so then what will happen sometimes is you might look at maybe a different time period. So we may say, well, okay, what's the probability that 7 homeless individuals will come in the next, so we're at the noon hour, what's the probability they'll come, 7 will come in the next 15 minutes? Well, now the mean changes. Now the mean is, the lambda is, instead of 10, it's now 1/4 of that, right? 15 minutes is 1/4 of an hour, so you've got 2.5 here. And that changes our probability distribution quite a bit. You can see now we're starting to get zeros, probabilities, pretty quickly here. Okay, and so our probability distribution could pretty much be cut off right there, right here. Okay, and you've got a new set of probabilities that we would have here. It's not, you can see obviously that these would be zeros, and then your mean and variance is 2.5 and so on. Okay, so that's the Poisson. Be able to calculate here, use the textbook, use Excel. They all should be pretty straightforward. And then the discrete uniform, there's really nothing new. In fact, basically what I did was I just copied and pasted from the the probability distribution, the discrete probability distribution video, the Excel file that I used for that video. I did change a little bit because I think in that one I may have only had 5 outcomes here, or 6 outcomes, 0 through 5. Here we've got 7 outcomes, 0 through 6. But the point is, for a discrete uniform distribution, however many outcomes there are, the probability is 1 over that number, so 7 outcomes. So the probability is the same throughout. That's why we call it a uniform distribution. So nothing else is new then. You can find the mean by taking x times the probability of x, summing those, you get a mean of 3. Right? You can find the variance either using the shortcut method or finding the difference between x and mu, squaring them, and weighting them by their probabilities, summing that, and you get a variance of 4, okay, which then gives us a standard deviation of 2. Let me know if you have any questions.